In the previous videos, I have explained about how to implement AND function and NOT function using McCulloch Pitts Neuron. In this video, I am going to explain how to implement XOR function or XOR function using McCulloch Pitts Neuron. This function is little bit different. So how to implement this function using McCulloch Pitts Neuron? So hello there, I am Shayan and you are watching Tec4Tric. So let's see how to implement this XOR function using McCulloch Pitts Neuron. First of all, we have to draw the truth table for XOR function. So here is the truth table. XOR function says that the output will be high or 1 for only odd number of ones. See, here we have x1 and x2 as the inputs and y is the output. 1 1, 1 0, 0 1 and 0 0 is the inputs. So for 1 1 it will be 0, for 1 0 it will be 1, for 0 1 it will be 1 and for 0 0 it will be 0. The output will be high for only odd number of ones. Here we have two inputs, x1 and x2. If you want to add more inputs, then also this definition will be true. The output will be high for only odd number of ones like 1, 3, 5, etc. But there is a problem. What is the problem? XOR function cannot be represented by simple and single logic functions. Then how to represent XOR function? This is how we have to represent XOR function. Like y will be x1 bar into x2 plus x1 into x2 bar. So if you don't know what that means, x1 bar, it basically means the complement of x1. If I put 1 here, it will give me 0. Like 1's complement will be 0 because it is in binary form. And if I give 0, then it will be 1. So now we have to add the weights like this, x1 bar into x2 into w1 plus x1 into x2 bar into w2. You remember previously it was only x1 w1 plus x2 w2, and here we have to write like this. Now let's assume w1 is 1 and w2 is 1 also. Now let's see how to calculate the net input. See, I have added w1 and w2 to their respective inputs and you have to calculate the y input, and this is the formula. So how to calculate it? So for x equal to 1, it will be 1 bar or 1's complement, that is 0. So 0 into x2 is 1, so 1, w1 is 1, so 1. So 0 into 1 plus x1 is 1, so and x2 bar, so x2 is 1, so 1 bar will be 0, so 1 into 0 into 1 equal to 0. And like this we have to calculate for the rest of the inputs, and we will get 0 1 1 0, and this is our calculated net input and this is our actual output. So as you can see, both are same. So how to calculate the threshold value for that? From the definition of XOR function, we can simply say that the threshold value or theta will be greater than or equal to 1 because the output will be high for only odd number of ones. And this is how we can represent XOR function using McCulloch Pitts Neuron. So y is the final output, f is the activation function, and this is how we can represent XOR function. Well, if you don't know what is activation function, threshold value, do not worry. I have already made a video about activation function and threshold value. I'll give it in the description box below. If you want to learn more about activation function and threshold value, please refer to the mentioned videos. Here it will be 1 if y input is greater than 1, and it will be 0 if y input is less than 1, and here theta is greater than equal to 1, and that's it for XOR function. This is how we can represent XOR function using McCulloch Pitts Neuron. Thanks for watching. If you learned something new, please hit the like button and comment down your thoughts, your queries. Please share it with your friends. And do not forget to subscribe this channel. I will see you in the next video.